Welcome to the sixth lecture of this week. In the previous lecture, we analyzed failure of a composite laminate using the total ply failure approach. Today, we will analyze the same laminate, but using partial ply failure approach. So, the laminate is same, it is a symmetric laminate. So, we have uh, 0, 45, 90, 90, 45 and 0, and we have till the first ply failure the analysis is same. So, we have seen that the first ply fails is ply number 3 and ply number 4. So, ply 3 and ply 4 fails at ply 4 fail at a load of Nx equal to 217 Newton per millimeter, and it fails in transverse tension. So, previously we set the stiffness of this ply to 0, but in a partial ply failure approach we are concerned with at what mode it fails. So, because it is failing in transverse tension, so we do not need to set E 1 equal to 0. So, E 1 remains same, that is 140 GPa, whereas E 2 and E 6 becomes 0. Now, we know that E 1 into nu 2 1 is equal to U 2 is equal into nu 1 2, and here E 2 is equal to 0. So, that tells me that nu 2 is equal to 0, because E 2 is equal to 0. So, if this is so, then for ply 3 and ply 4, we have Q 1 1 is equal to E 1 by 1 minus nu 1 2 nu 2 1, and that is 140 GPa, and then we have Q 1 2 is equal to E 2 into nu 1 2 by 1 minus nu 1 2 nu 2 1 equal to 0, and then we have E q 2 2 is equal to E 2 by 1 minus nu 1 2 nu 2 1, which is equal to 0, and Q 6 6 is equal to E 6 equal to 0. So, with that the Q matrix in the 1 2 system that we get is 140 0 0 0 0 0 and 0 0 0 in GPa. Now, for this in the XY system it is a 90 degree ply. So, this matrix becomes 0 0 0 0 140 0 and 0 0 0 GPa. Now, the Q for QAXY, QX for XY for other plies remains same. So, with that the new A matrix that we get is this: A is equal to 46.3, 9.325, 8.175, and we have 9.325, 48.825, 8.175, and we have 8.175, 8.175, and finally, we have 9.825 kilonewton per millimeter. So, with this we can again find out the epsilons. So, we know that Nx, Ny, Ns is equal to A matrix into epsilon x, epsilon y, epsilon s. So, A we have found out here, Nx we know that is 217 Newton per 217 Newton per millimeter, and this quantity is 0, this quantity is 0. So, with that we find out epsilon x, epsilon y and epsilon s as, now again remember it is a symmetric matrix. So, there is no kappa because the load is only axial. So, epsilon x, y, s are same as epsilon x 0, y 0 and epsilon s 0. So, with that we get 5512 minus 326 minus 4340 into 10 to the power minus 6. Now, let us look into the individual plies. So, let us look into plies 1 and 6, and these are 0 degree plies. So, for them epsilon x, y, s and epsilon 1, 2, 6 are same. So, epsilon 1, 2 and 6 are 5512 minus 326 minus 4340 into 10 to the power minus 6, and then we can find out the stresses. So, sigma 1, sigma 2, sigma 6 can be obtained by multiplying these epsilons with respect to principal material direction by multiplying with the matrix of Q with respect to the principal material direction, and the stresses are found out to be 776, and then we have 13 and minus 22, and we get this as Newton per millimeter square. Now, for failure, as we did before, sigma 1 needs to be amplified by a factor 1550 or 1500, because this is tensile stress. So, we will divide the tensile strength by that. So, this is 1.93, sigma 2 to be amplified by 50 by 13, and the factor is 3.85, and sigma 6 to be amplified by 70 by 22, and that is factor is 3.18. Now, let us go to plies 2 and 5. And they are 90 degree plies. So, for them sigma 1, epsilon 1, epsilon 2 and epsilon 6 has to be obtained from the transformation matrix, because they are not aligned along the principal material direction, and the transformation matrix becomes this. And the strengths are found out to be 423, 4763 and minus 5838. So, here the engineering definition of strain is used. So, that is why we see that these two quantities and these quantities there. So, now, we find out the stresses. So, sigma 1, sigma 2 and sigma 6, and this we multiplied with Q matrix with respect to the 1-2 system, and the value becomes, this is 423, 4763 minus 5838 into 10 to the power minus 6 into 10 to the power 3 Newton per millimeter square, and the stresses that we find is 73.89, 49.37 and then we have 29.19 megapascal. So, now, we can see that this value is very close to failure, because the transverse tensile strength is 50 and this is 49.37. So, needless to say, this is going to fail, this laminate is going to fail at this mode at ply 2 and 5, and the corresponding failure load is, so ply 2 and 5 fail at Nx is equal to 246 and 246 Newton per millimeter. So, if I just divide 50 by 49.37 and then if we multiply 217, this is the load that comes, and this fails in transverse tension. Now, because it fails in transverse tension, so we again need to adjust the stiffness of the these plies. So, ply 3 and ply 4, the stiffness adjustment we need to again do. So, with that if we do all the adjustment and recalculate the Q matrix, the Q matrix becomes 1 1 1 1 1 1 1 1 1, we have 35 multiplied here, and GPa. So, E1 is 140 GPa and E2 is equal to E6 is equal to nu 21 equal to 0. So, with that again we can find out the new A matrix, and the A matrix is found out to be 43.98, 9.5, 8.75, 9.5, 46.5 and 8.75, and we have 8.75, 8.75, 10, that is in GPa millimeter. Now, we can find out again the strengths. So, we know Nx, Ny, Ns, and we have the A matrix, and we multiply epsilon x y epsilon s again. So, epsilon x y s are equal to epsilon x 0, epsilon y 0 and epsilon s 0, and this quantity is now 246 Newton per millimeter, this is 0, this is 0. So, with this the strengths are found out to be epsilon 0, epsilon x 0, epsilon y 0 and epsilon s 0. The strengths are found out to be 6790 minus 320 minus 5658 multiplied by 10 to the power minus 6. Now, let us look into ply 1 and 6, those are the plies yet to fail. So, plies 1 and 6, and those are 0 degree plies. So, for them epsilon 1, epsilon 2 and epsilon 6 are same as epsilon x, epsilon y and epsilon s. So, 6790 minus 320 minus 5658 into 10 to the power minus 6. Now, we can find out x sigma 1, sigma 2 and sigma 6, and for that we multiply the Q matrix in the 1-2 system, that is its Q matrix with x y system also, and then we have epsilon 1, epsilon 2, epsilon 6, and the values that we get are 955 MPa, 17.14 MPa, minus 28.29 MPa. Now, for failure, sigma 1 is 2V, amplified by a factor 1500 by 955, which is 1.579. Sigma 2 is 2B, amplified by a factor 50 by 17.14, which is 2.917, and sigma 6 2B, amplified by a factor that is 70 by 28.29, and that factor is 2.47. So, we can see that this is the lowest factor. That means, the ultimate failure load is whatever we have 246 multiplied by 1.579 Newton per millimeter, and that gives me a value of 388 Newton per millimeter. Now, the plies, the 90-degree plies and 45-degree plies have already failed, and this ply is also failing now. So, this is the ultimate load it can carry. So, with the partial ply failure approach, the ultimate load for last ply failure is 388.4 Newton per millimeter. So, with this numerical example, let us end this discussion here. Thank you.